Welcome to a new lesson. In the previous lesson, we studied about HDFS blocks. In this lesson, we'll deep dive into HDFS architecture. HDFS works on master-slave architecture. Name node is the master node and data nodes are the worker nodes. That means name node would be responsible for all the management of the storage space on the data nodes, and data nodes would do the actual groundwork of storing the data blocks. Name node performs the function of keeping a track of the complete file system by managing two things. First, namespace image, and second, edit logs. Namespace is the metadata about the files and directories which are stored in HDFS. It contains data about all the blocks, to which files they are associated with, and on which data nodes it resides. Edit log is nothing but the log of activities on HDFS performed by the client. Edit logs just keep on piling up and grow as the activity on HDFS keeps on happening. So out of the two, edit log is the one which keeps on growing at a faster pace. These two combined form the complete file system image, giving details of all the files and blocks on HDFS. The block information is updated by the name node as and when data nodes join the network. That means as soon as a data node boots up and connects to the network, it would send name node the information about the blocks it has, and thus name node would update the namespace image with the data. Both edit logs and namespace are maintained in the main memory of name node. This helps name node to quickly look up for the blocks as and when required. Now let us take a look at the case when the name node fails. As you can guess, the complete file system would go down and would be unavailable as complete namespace image and data block information is lost. For this reason, name node is also referred to as single point of failure (SPOF) in HDFS. That is why it is important for the name node to be resilient to hardware failures, and it is highly advisable to spend more on name node's hardware. Still, with upgraded hardware, failures can happen. To counter those situations, following resilient addition is done. The namespace image and edit logs are transferred to a highly available remote interface mount by name node from time to time. Additionally, secondary name node is also added. Do not confuse it to be like another name node. This is considered to be one of the naming blunders in Hadoop. Secondary name node doesn't function like name node. Its main and sole purpose is to combine the namespace image and edit logs so that name node's main memory doesn't fills up because of the ever-increasing edit logs. Secondary name node also creates checkpoints of the namespace image and edit logs merged together and writes it to a file. This helps name node to release the main memory occupied by the edit logs till the point of last checkpoint. And this is the only purpose of secondary name node. Secondary name node is a Java program which just combines the edit logs and the namespace and creates a checkpoint. That's it. This operation of combining the edit logs and namespace is itself complex and CPU and memory intensive. So secondary name node needs to be running on a good hardware configuration, as the job of combining the edit logs and the namespace requires good computing resources. At this point of time, I just want to remind you that the name node and secondary name nodes are nothing but Java programs that run with main classes as name node and secondary name node. So in case of failures of the name node, Hadoop administrator needs to boot up a new name node.